My name is Abhay Tipimut, and my project is predicting the unseen at TANGO2 detection. Okay, so my problem statement. So TANGO2 is a deficiency disorder, and it's a rare and life-threatening genetic disease that predominantly affects children. And this disease is so rare that 1 in 1.3 million people worldwide are affected by this disease. And alarmingly, about 60% of patients don't survive past the age of 9. And TANGO2 deficiency leads to severe symptoms such as seizures, cardiac arrest, developmental delays, and intellectual disabilities. And one of the most pressing challenges that we face for this disease is early detection. Unfortunately, because of how rare this disease is and the lack of data and biomarkers and these different signs that help detect the disease early is very hard to find. And as a result, many children are diagnosed way too late, and it significantly reduces their chances of survival. And this shows the importance of early detection for TANGO2, which is why I took this project. Okay, so why this problem matters and some of the facts and statistics of this. So first we have the high mortality rate. As I mentioned before, approximately 60% of children with this disorder do not survive past the age of 9, and this shows the urgency in like addressing this disease. The second thing is the severe and life-threatening symptoms associated with TANGO2 deficiency significantly impact the quality of life for the affected individuals because it can cause seizures, cardiac arrest, and it also poses like immediate threats and long-term like health complications if they do end up surviving. The third is that the difficulty in early diagnosis. So the absence of specific symptoms or biochemical markers, that means that the cases go undetected for like a long period of time, and this delay can be super devastating and have lifelong consequences. And then the fourth one is limited awareness and research. So many healthcare providers may not even be familiar with what TANGO2 deficiency is because it was recently discovered in January of 2023, and this further delays the diagnosis. And then lastly is the impact on affected families and healthcare system. These families can face like emotional, financial, and psychological burdens because of how expensive treatment can be for a disease that many people have not even heard of. Okay, so my engineering and research goal is to develop an AI-powered early detection system for TANGO2 deficiency disorder by integrating genetic, clinical, and environmental data. My project aims to provide a reliable tool for timely diagnosis, improving patient outcomes, and enabling earlier interventions to save lives. Okay, so the data collection. So given the rarity of this condition, I found platforms like Kaggle didn't really have much data or information on this issue. So I had to find different places to get the data for my project. So first I used like official websites like the CDC and the TANGO2 Research Foundation. So these gave me important data and statistics about like the cases, symptoms, the genetic makers related to this disorder. And this was some of the data I used for my model. And then also my neighbor's sister is one of the first doctors in Texas to study the TANGO2 deficiency disorder, which is kind of how I got inspired to work on this project. And so with her firsthand knowledge, I was able to like learn from her experience about dealing with these cases and how learn a comprehensive view of the TANGO2. And then because this is using patient data, I have to follow the HIPAA or HIPAA guidelines, and I made sure to follow that. Okay, so my approach to diagnose the patients based on the data set. So these are some of like the steps kind of I used to do my approach. So the first is data processing. I clean and prepare the data set, converting the categories into numbers that the algorithms can use. So like in any AI or data science model, you have to like clean the data. You have to make sure there's no missing sets and make sure that all the data is accurate. And then so I also had to convert the data into like categorical information because for example, like patient, like the models can't just take like male and female and they can't just like predict. You have to convert them into categorical numbers that the models can understand. So I had to convert, for example, male and female for the gender of the patient. I can convert it, male could be 0 and then female could be 1. So I had to like convert those using a data dictionary to help convert the data. And then feature selection. So I chose like the specific parts of the data set that I have to train the model and use it, such as genetic information, the symptoms, and the environmental factors. And then I trained my model using a random forest and then where the I trained the model using the random forest classifier, and the data set like targets specific tables in the data to find and detect the TANGO2 deficiency. And then after that, I just used a validation data set. So I split my data set 80-20. So 80 was used for training, and then 20% was used for validation. Okay, so the techniques I used a neural network, the CNN model, and it was just used to identify these patterns. And this helps predict if the TANGO2 deficiency by learning from other features associated with this disorder. And then I also used another AI model called the random forest. And so it combines like multiple decision trees. So it's like a decision tree, like one path leads to another, like that. And this just helps improve the accuracy and reduce errors that my model could have. Okay, so on to the model development. So first, for the neural network architecture, I use like several layers. So it starts with an input layer that takes like different features of the data. There are two hidden layers in my model, one with 32 neurons and then the other one with 16. And the larger layer is like for more complex features. And then the second layer is like for refining these features to have like better prediction accuracy and stuff like that. And then, so I used the ReLU activation function. So what this basically stands for is the rectified linear unit. And so what it does is it takes like it learns from the complex patterns, and it takes like positive values, and then it turns them into unchanged negative values in zero. And so this keeps like the network more efficient, and it prevents like any issues that might occur in the CNN model. And then there's an output layer with like one neuron, and I use like a sigmoid function, which is just like takes values from the previous layer and transform into like a probability between 1 and 0. And this probability is like what I use to predict whether the patient has TANGO2 or it doesn't, and it helps for like early detection. And then the random forest classifier is just it's a AI detection model. So basically, it just uses different decision trees, and then it's trained on different parts of the data, and then it just when it comes to making prediction, it takes like the final tree that has the most votes, and so this can help like increase accuracy in the model prediction. These are like some of the code snippets that I used. I used the PyCharm IDE. So this is to help. This is the random forest classifier on the left, and then the right is the CNN model that I trained. I can show you this in PyCharm later. So these are some of the metrics that I used. So first we have like accuracy. So this just tells us like the percentage of the correct predictions that the model made. And then the next is the confusion matrix. It's to visualize like the performance, true positives, true negatives, false positives, and false negatives. And it just shows where the model's making mistakes. And then the next is the precision and recall. So this shows how many of the predicted positive cases are actually true, and then how many of the positive cases were actually identified. And then this just shows like a kind of like a complete picture of like the model's accuracy. Okay, so this is the model comparison. So these are the two confusion matrix that the models like outputted. So starting with like the neural network, it achieved an accuracy score of 85% on the validation data set. So this means that the 85% of the predictions were accurate. And then going on to like the precision. So the precision tells us how many of the predicted cases were actually true. And so for class 0, which represents the non-TANGO2 cases, so my data set contained both to help train the model, it was 0.083, which is like 83%. And then for class 1, representing the TANGO2 cases, it was 0.66. So the recall shows us how many actual positive cases were correctly identified. And so going on class 1, class 0, that just shows non-TANGO2 cases and TANGO2 cases. And then now looking at like the random forest classifier, it was an accuracy score of 80%, and the precision for class 0 was 75, and it was 0.066 for the class 1. So and then in terms of the F1 score, it was 0.078. So the F1 score just shows us how well that the model is performing in like an overall comparison, calculating using formula for precision and recall. And so basically after using all of this, I could tell that the neural network was used for predicting more effectively used for predicting like the non-TANGO2 cases. And then the random forest classifier, because it uses decision trees more effectively, it was better in predicting the cases that have TANGO2, which is why my like model uses both of them. Oh, yeah, and then conclusion. So this is just like reiterating some of the important stuff. So like the significance of my project, it developed tools for like detecting TANGO2, impact of early detection because 1.3 million, 1 in 1.3 million children have this, so it's very rare, so it's very hard to detect it. And then some of the limitations is like it may not represent all the affected individuals, and we do need a little bit more research because of how rare it is to validate my findings. And then in the future, just like better accuracy and then maybe extra data. And yeah, that's it. Thank you for listening.